morning, respected colleagues and participants. It's our great pleasure to present our research entitled Study of the Influence of Flocculant Dose in Wastewater Treatment. This work has been conducted by our team from Bucharest State University in collaboration with Kathmandu University. Let me begin by sharing the background and motivation of this study. Flocculation is one of the most widely applied processes in industrial wastewater treatment. It plays a crucial role in removing colloidal and finally dispersed pollutants such as surfactants, petroleum products, oils, proteins, and metallic oxides. Since these contaminants are too small to be removed by ordinary sedimentation, flocculants become an essential tool. In this research, we evaluated the performance of synthetic organic flocculants for wastewater originating from petroleum refining and textile industries. Now, let us move to the materials and reagents used in this study. In our experiments, 9 flocculants formulations were tested. These included polycromolate-based reagents and their derivatives, carbamazepine cellulose, and hydrolyzed polycrolatoline. We carried out tests on both model emulsions and real industrial wastewater samples. The objective was to identify which flocculants perform best in terms of turbidity reduction, COD decrease, and suspended solids removal. Next, I'll explain the methodology that guided our experiments. To study flocculation performance, we examined the influence of dose, mixing intensity, and pH on treatment efficiency. Viscosity measurements were performed to assess the stability of flocculant solutions. We also measured electrokinetic potential to track particle charge modifications. Additionally, natural clays activated by UV radiation were tested as sorbents for copper and nickel ions. Having established the methodology, let us now consider the physiochemical properties of the flocculants. The viscosity isotherms of different flocculants showed a nonlinear increase in reduced viscosity with dilution. This effect was especially pronounced in ionic flocculants. Such behavior is explained by the unfolding of macromolecular coils and their expansion in water. These structural changes are directly related to their performance during wastewater treatment. When flocculants are diluted, the concentration of counterions decreases. This leads to stronger electrostatic repulsion between like-charged units in the polymer chain. As a result, the size of macromolecules increases, which enhances ion accessibility and flocculation efficiency. However, the optimal dose depends not only on the flocculant structure, but also on molecular weight, ionic strength, and solid phase concentration. This brings us to the next section, where we analyze the influence of dose on flocculation efficiency. Our results showed that the optimal dose of flocculants range from half to 7 mg per liter. For instance, FLPG6 and FLPC5 achieved over 93% removal efficiency at very low doses. This demonstrates that small amounts of well-structured polymers can provide highly effective treatment. However, excessive concentration leads to viscosity increase and even gel formation. In the next section, I'll show how storage stability further affects performance. Storage time had a clear impact on flocculant viscosity. For example, FLPC5 maintained high viscosity for up to 6 months, while diluted solutions degraded much faster. Reduced viscosity, therefore, serves as a reliable indicator of polymer stability and shelf life. This insight is crucial for industrial use, where long-term storage is often required. Now, let us consider the sedimentation behavior of flocks during treatment. Sedimentation is the final step that allows flocks to be removed from water. The rate of sedimentation depends on both the size and density of flocks, which are determined during the flocculation stage. According to Stroke's law, larger and denser flocks settle faster. Our experiments showed that under optimal conditions, flocks could grow up to 1 millimeter in size. Let me now present additional results that confirm these findings. Measurements of kaolin suspension flocculation revealed that flock size increased steadily during slow mixing, but only up to a certain point. After about 6 minutes of mixing, no significant growth occurred, indicating the completion of flock formation. These observations confirm that both mixing time and flocculant molecular weight play decisive roles in sedimentation behavior. Next, let us examine how these findings were applied to reveal refinery wastewater. In the case of oil refinery wastewater, flocculants such as FLPC5 and FLPG6 performed exceptionally well. They reduced turbidity by more than 90% and achieved chemical oxygen demand reductions of up to 86%. These results clearly demonstrate the suitability of high molecular weight ionic flocculants for large-scale treatment. Next, I'll show you the performance of flocculants in rainwater treatment. In rainwater purification, cationic flocculants such as FLKJ8 were compared with FLC2. FLKJ8 proved more effective due to its higher viscosity, especially when combined with filtration. Both turbidity and COD levels were significantly reduced, demonstrating strong treatment potential. However, further details are better understood from a more in-depth comparison, which I will show in the next slide. In detailed laboratory tests, FLKJ8 reduced turbidity from as high as 173 mg per liter down to just 2 mg per liter. Petroleum products decreased almost threefold, while COD was reduced by more than half. These results confirm that selecting flocculants with favorable viscosity and charge characteristics greatly improves treatment efficiency. With these findings in mind, let me now summarize the overall conclusions of FOR research. To conclude, our study comprehensively evaluated the impact of flocculant dose, molecular weight, and physiochemical properties on wastewater treatment. We found that optimized flocculants can achieve up to 95% contaminant removal at minimal doses. Among the 9 formulations tested, FLPG6, FLPC5, and FLPU7 consistently showed the best results for both refinery and rainwater wastewater. These findings highlight the potential of tailored flocculant systems for sustainable industrial water management. Thank you for your kind attention, and we welcome any questions.